Now let's talk about the high voltage generator and rectifying. This part of the system takes the voltage from secondary side of the auto transformer and produces kilovoltage, or the kilovolt peak that we want, ultimately in the X-ray tube. So there are three parts to it, of the high voltage generator. Last time we talked about the operating console, MA, and time. Now what we're going to be talking about is the high voltage generator portion of our entire circuit. So you probably learned in Mrs. Cox's class that we use a high voltage generator in pretty much every X-ray system these days. So this part of the system takes the voltage from the secondary side of our auto transformer and produces kilovoltage, or the kilovolt peak that we would like, and that we set on our operating console. The three main parts of this system here is the high voltage transformer, the filament transformer, and the rectifier bank. And the broad overall from outlet to tube and X-rays, in this circuit diagram here, we can see the control console part is kind of what you said and what you've decided on for the MA, for example, our kVp and our time. Now we're getting to the high voltage section, which is what takes the things we set and sends the things we need to the X-ray tube here. It's kind of the in between what we set and then what we're getting. So with a high voltage transformer, what we have is a certain number of windings on the primary side and a greater number, always a greater number of windings on this secondary side. And this is, again, a step-up transformer. And it's showing us here, we go from voltage on this side, we radiate out those flux lines, those alternating current flux lines, so they're constantly fluctuating, and then that induces a current and energy to flow in this winding. So again, we go from voltage to kilovoltage. What happens now, though, with our kilovoltage is that we are going to send that off to a rectifier bank. We need to rectify the alternating current that we've been working with and that we had to have for this step-up transformer here. We have to work with it and now convert it to DC, basically. While AC was required for transformation of voltage to kilovoltage, now we need direct current so that the cathode is only negative, the anode is only positive, and our electrons are going to go in one direction only, from cathode to anode. So what helps us do this are rectifiers or solid-state diodes. Now, if you recall, a semiconductor is something that in a certain environment, it'll conduct electricity, and when that environment's not quite right, it acts as an insulator, which does not conduct electricity. And that's exactly what this semiconductor is doing. And it shows you a little image here of the actual rectifier bank here. Now, what this is saying is that we have our energy here. We still have alternating current. Now it's going to pass through these circuit elements that say, okay, we'll conduct electricity for you here in this part of the waveform, but not here. It's going to stop the electron flow there. Go ahead, it's going to let electricity flow, but not down here. So what we end up getting is something that looks like this. Flow of electrons, nothing. Flow of electrons, nothing. And here we can see. Now, what this can create is a gap. So what that would mean in the X-ray tube is that you're getting X-rays here, getting X-rays, and then all of a sudden nothing happens. Getting X-rays, nothing happens. Think of these waves here as a reason for electrons to move and X-rays to be produced. We're creating that potential here. Now, what we can do using these rectifiers is instead of having a blank space here, we can recycle that wave that was down here and put it up here. So now we have X-rays, 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 and we don't have that gap, which was otherwise just wasted time. Now, again, what this ultimately does is it puts a consistent positive on the anode and a consistent negative with all those electrons there at the cathode on that cathode side. So what this does is creates an incredible potential between the negative of the cathode and the positive of the anode. Now, instead of getting 60 hertz per second or 120 waves that we were getting out of the outlet here, what we can do is use a high frequency generator and get up to 50,000 waves, or much more waves to work with. So now we never have a value that drops all the way to the bottom here, to 0. Now, what does that mean exactly? Well, let's take a look here, and that's a conversation about voltage ripple. So here we had our real inefficient, really old equipment where we have 100% ripple, and it's only half rectified, meaning that other part of the wave wasn't recycled yet. In this case, we have 100% ripple, and what that means is we start at 0 here, down at the line, and no X-rays are produced because there's no potential. There's not a positive on the anode and negative on the cathode that wants to make everything start to move. We have nothing. But then up here, we have our 70 kVp. And then it drops back down to 0. 0 kVp, no X-rays. When we have our really efficient units, all the new stuff, what we use now, high frequency, we have 1% ripple. Now what this means is if we set 70 kVp, we're going to get 70 to 69 kVp for as long as our exposure is going. So we're only ever off by about 1% or less, meaning that if we set 70 kVp, we're getting 70 kVp.